Welcome everyone to today's webinar. My name is Ian Watt. I'm the General Manager of the CMS Group, the company behind SmartSpec. I want to thank you for joining us. This is the latest in our webinar series regarding H1. Today we're going to focus on floors and foundations. And I'm very pleased to be joined by a representative from someone we work very closely with, Firth. Thanks, Greg, for joining us today and introducing you to everyone out there. Greg's role is as constructive systems specialist. And he's going to kick things off just with an overview on the impact of H1 for foundations and a little bit more information around the range of solutions that are available from Firth to help you comply with the requirements around the new regulations. Once Greg's presentation is finished, we'll then cover off some of your questions and answers that we've received throughout the last few weeks. So without further ado, I'd now like to hand over to Greg.
Morning, everyone. Right, so in the past, before this change, all concrete slab on grade foundations were deemed to comply with the minimum R value, which was 1.3. So not a lot of thought was given to this. So it has been a big change where now a lot more consideration is to be given. Another thing to consider is the increase appears to be small from 1.3 to the new 1.5 and 1.7. One of the reasons that the change isn't as small as people think due to the methodology change. So they've changed how the R values are calculated for foundations. The big change would be the ground thermal conductivity. In the past, the ground was considered to be 1.2, having a greater insulation value. And now the ground's considered to be 2, which means that a lot more heat loss is lost from your foundation into the ground. So that's the reason for the changes in the any R values that are tabled from any manufacturer or supplier. Here you can see this is from the Ribraft technical manual, and you can see how we tabled our R values previous to the 1st of May. And you can see the differences. So if you look at 2, for example, the area to perimeter 2 has gone from 1.75 down to 1.13. It's a pretty big difference, meaning that it's not a 0.2 or 0.4 difference. And this is what's causing the confusion. So you need to consider that any manufacturer's tabled R values need to be, you need to ensure that they correct as of in 1st of May. In the front of the H1 AS1 document, the wording energy efficiency for all housing, and buildings up to 300 square meters, that alone is causing some confusion. I did a presentation to the Auckland Council building inspectors recently, and they misunderstood this. So H1 AS1 includes all residential buildings. Some people still questioning it that they feel if it's a residential building greater than 300 square meters, it needs to be moved on to H1 AS2, and that's incorrect. The buildings up to 300 square meters is for commercial buildings. Anything other than residential buildings. I had a look through the questions that were submitted pre the webinar, so I'm going to try to cover off some of those as we go. Extensions and alterations to foundations and buildings comes up pretty regularly. What's important to consider here is if it's a new foundation that's been built, then that part of the foundation needs to comply with the new minimum H1 clause, which would mean if it's a small addition and it's a concrete floor, it's going to need to be fully insulated to comply with the new minimum requirements. If it's a renovation that's not affecting the floor and the floor was built pre-1st of May, or consented pre-1st of May, then nothing needs to change on the floor. It's the same that goes with the rest of the building. If it met the H1 at the time of consent and construction, then it doesn't need to meet the new H1. It's just the new construction. In the back of H1 AS1, there's the tabled R values to the area to perimeter ratios. This information can't be 100% relied on, in my opinion. For example, the hot edge for brick veneers, you can see the detail there. We need that 25 mil concrete to transfer the brick veneer load back into the foundation. So we're not comfortable with taking the hot edge directly underneath the brick veneer. If you look at the tables, it states an R1 edge insulation full height. So it's not possible to get it and comply with the B1 code. So this is why every material manufacturer or supplier actually needs to thermal model their own systems, and in my opinion, not rely on the information in H1, AS1. So we thermal modeled all of our different systems. At the time, we were looking at different options to try and cover off every solution. And for heated floors, non-heated, for X-pod, rib raft with a 220 mil pod and rib raft with a 300 mil pod. We tabled this information into a calculator. It's a very easy step. I'm sure many of you are aware of it. So I won't go on about that, but it's a super simple tool and easy to use. One of the questions that comes up is the insulation between conditioned and unconditioned spaces. The best way forward with this is to not insulate that area, to not try and have a thermal break that's built into the slab. So the solution would be to make a correction. So you just deduct your edge insulation, your length of perimeter with no edge insulation off your overall result. This is the same as in the brand's house insulation guide. They have this correction table. So I'll show you how it works on the Firth R-value calculator, because this is coming up quite a lot. So there's just your basic slab and garage area without the hatching, for example. So your area excludes the garage area. Your perimeter, it now becomes the full perimeter, but is an internal 6 meter and 6 meter, the 12 meter section. That's your new perimeter. So you can select the box where it has slab as part of perimeter with no edge insulation and enter your numbers. So that's 12 meters, and the calculator does a correction on a percentage basis. Just as an example, you'll see a detail pop up. This is the same floor slab as an example. Your area to perimeter ratio is 2.4, 23% without edge insulation. So if you use hot edge extra and a hot edge base in this scenario, you get an R value of basically 1.6. Questions I'm being asked, people are not seeing the drop-down box. So purposely I'm showing the slide. At that stage in the calculator, you can drop down the box and see all the other insulation scenarios we assessed. The calculator will always find you an optimal result. You can go below minimum, see what, for example, so this optimal was hot edge extra and hot edge base. You can go below and just use the hot edge extra and eliminating the base, or you can eliminate all edge insulation and see what your R value is. So same example would give you an R value of 1.27 with no insulation. And obviously this is the PDF that you could then submit for building consent if you're wanting to use the calculation method, where you don't meet the minimum and you're using a lower value for calculating. This was a project I worked on with a designer. He had these 4 units and he was looking at what he needed to do to get to the new R values. Eliminating the garage space is what is required as it's non-habitable, non-conditioned space. The AP ratio is 2, so the area to perimeter ratio is 2. Uninsulated standard rib raft system, R value is 1.1. Now, in my opinion, if you can insulate that garage area, you're going to increase your area to perimeter ratio to 3.2 on the exact same job. That uninsulated R value is 1.5 and complies with the minimums in zones 1 to 4. That would also eliminate the need for the insulation of the first story floor, so the underside of that floor in the garage space. So possibly a cheaper option. And I know there's some work being done on garage doors. So if we could include that, that would be, in my opinion, a better result on this kind of style build. The hot edge system been around for about 7 or 8 years. Obviously, there was a lot of talk with edge installations coming from many years ago. It is no doubt the most complete system on the market. You know, we offer a free material take-off service. We've got a brick veneer option. We've got framing options, a corner bracket that makes the system pretty neat and more durable. Dandam tape to prevent leakage when concrete's poured between the boxing and the hot edge. And then the tornado screws anchor the board into the slab. And obviously, being a product that's installed in situ, it doesn't need an extra trade to come on site to apply, and also another extra trade to plaster. Anybody that knows, if you've tried to plaster something like that at ground level, it's not an easy process. And then we also sell it with a tidy up product. So if it's ever, you can patch small imperfections in the plaster. Just a basic slide showing hot edge extra and a brick veneer on the right-hand side there. You can see the 25mm concrete that's needed. One of the questions that did come up was the brick veneer and the heat loss path. And obviously, the thing is, even if you did have that edge insulation right up to the underside of the brick veneer, you would still have a heat loss path because heat takes the path of least resistance. Will go through the concrete, which is the dense material, and then go through the brick veneer, which is the dense material, and out. But the improvements that the edge insulation offers is still fairly similar to a framing solution. Another question that's come up a lot, can I use underslab insulation without edge insulation? And this is possible. And the calculator, even though it wasn't designed for this purpose, can be used in this instance. So you would do your area normal, your perimeter normal, your framing normal. Select the box where part of the perimeter has no edge insulation, and then put in your full perimeter. So your full perimeter length, in this case, 85. And our percentage of total perimeter length will be at 100%. At the end of the process, it will give you, even though it still says hot edge extra on the solution, it's giving you an R value with no hot edge because you've eliminated the entire perimeter edge insulation. So the result is 1.8 on a, I can't remember the AP ratio on this one. I've written it. Yeah, there. That's our AP ratio of 2. Another question was, how do I prove this to the building consent officers? We supply a PDF at the end of the process with the calculator. In this instance, I would recommend highlighting the fact that you've got no edge insulation and it's 100% because the solution still says there's edge insulation. But that would be your correct construction R value with 50mm of EPS underslab and no edge insulation. The WANS bar detail with hot edge, we're getting asked about a fair bit. This detail is in the hot edge install manual, so we've tried to make it clear. You can't fix anything rigid through a non-rigid board to get a secure fixing. So in the location of step downs or joinery details, you need to just leave a 25mm gap from your fixing, your WANS bar fixing, to the top of the hot edge. Another one that's very topical is the wall plate anchors, a solution that everyone's currently dealing with. Firth are front footing this in a great way. We have done some brands testing on a wall plate anchor at 11 degrees, and the results are really very good. Currently, what we're doing is insisting that this, if people wanted to use the system, they can use the data from the tests and the data that we've released, but we're just saying that the wall plate anchor needs specific design from an engineer. And this is based on the fact that we aren't there to monitor construction tolerances. if the frame overhangs more than what's specified, or the bolt didn't go in at 11 degrees, the building inspector is going to phone Firth. We're not there on site to monitor this, so it's better if an engineer can. It's a simple solution if something didn't go exactly to plan on site, and it might be just a matter of installing bolts at closer centers. But what we're also currently working on is we're working at the wall plate anchor company with a jig that will ensure that the bolts are drilled at 11 degrees, and also an anchor, a bracket, a wall bracket similar to a handy brack that can cope with all the loads. We're going to brands test these in November, probably the end of November. So hopefully, with any luck, we'll have our report out before Christmas, but can't be sure. And then that will be hopefully a system that just comes with a PS1, and we can continue to look forward with this. 140 framing solves a lot of issues with H1 for slabs and walls, I guess. And I was made aware of a study that Brands did a few years ago. So they took 47 houses and they looked at how much timber framing, what the timber framing percentage is in the walls. And the average was 34%. The industry is still working on an average of between 14 and 18%, but they came up with an average of 34%, meaning there's a lot more timber in a 90mm frame wall, meaning there's a lot more heat loss path through there, and a lot less insulation can actually be fitted in the gaps between the framing. Just for an example there, if you took a material R value of 2.8, which is the maximum you can put into a 90mm frame wall, and your framing was 23%, the insulation, the construction R value you can achieve is only R2. So it tells you there that if your average is 34% and you're putting in your maximum insulation in the wall, are you actually achieving your minimum R2? So obviously going to a 140 frame that can easily be solved. Wall plate anchors become more simple, but we do understand there's issues with the amount of timber that maybe there's reluctance to move to 140 framing. The Brands House Insulation Guide 6th edition, again, this highlights the same thing. You've got on the right hand side, well, in yellow at the bottom is your material R value 2.8, and it shows you at 23% framing, the number on the right. Anyway, same thing, it's R2 at 23%, and as soon as it's 25% or more, it's not achieving the R values. If you use Design Navigator, it's still based on average of between 14 and 18%, and you can go down with your material R values to a 2.5 or 2.2 and still achieve minimum R values. Another thing we've been working on is if we could move the insulation inside of the floor. Firth did a lot of work on this prior to going to the thermal modeling. We looked at aerated concrete below slabs. We've looked at even reducing the thermal conductivity of the concrete, if we could get that right, and see what benefits we could achieve out of that. One we're looking at currently is internal insulation. So this at just 30mm thick, as an internal cork-based screed, can achieve a 0.6 on the floor. Obviously, that's quite a decent improvement and can get you across the line in most instances. Also, at the end of life, this would be completely recycled, meaning that you wouldn't have anything going to dump. It's a shame we're looking at insulation and we're looking at polystyrene again, when a lot of the drive is being towards plastic pod systems and trying to eliminate polystyrene. So it's not like we've stopped looking, it's just the EPS is available for current solutions, but we'll keep looking for more greener solutions in the future. Something that's also been causing some confusion, the Firth code mark system never did include hot edge or underslab insulation. So we're currently going through the process of revising the code mark. We put up a note on our website saying that the code mark was invalid, I guess. We've made that more clear now. We reworded this. The code mark can still, the riprap code mark can still be used as long as there's no additional insulation. So it's a standard riprap buildup. There's no reason why you can't use it. And the only thing that isn't current is on the certificate would be the H1 code. But if you show compliance through a Firth calculator, for example, and you can see your R value that way, then there's no reason why you can't use the code mark as is, as long as there's no additional insulation. So no underslab and no edge insulation. And that's everything I've got covered in the presentation. Yeah.
Cool. Thank you, Greg. We'll now take to some of the questions. I know you've answered some of these, but we'll try and find some that perhaps we ain't covered. Someone out there is asking your opinion regarding the thermal separation between conditioned spaces and unconditioned spaces within the slab by using vertical slab edge insulation.
When that was first brought up, we actually raised it with MB to say that's it's a very heavy engineering detail. You know, it may involve 2 concrete pours. You're going to have an insulation board between the slab, and you're going to need reinforcing to pass through that insulation to tie the 2 slabs together anyway. It's not something we could ever consider code marking. It's too engineering heavy. And you would have heat loss path anyway from your, so it's not a very successful detail. And I think that's why if you look at the Brand's House Insulation Guide, their guidance is to go more towards just eliminating that section. So the section between the conditioned and unconditioned, you don't have an edge insulation in that area.
Okay. You covered it off in your presentation, but perhaps just to reiterate there. So the way to prove the R value from Firth's perspective to the Building Consent Authority is UPDS.
Yeah,
I'm
glad you kept that one in there because I can definitely elaborate on that. You know, it's we have to, as a material supplier manufacturer, we have to prove our systems and prove our R values. And the reason why I don't think that the tables in HS1 can be relied on is, I mean, there's a few. They're saying that the edge insulation needs to go from top to bottom. And it's R1. So the figures that they give you there, they R1 material R value, and it's top to bottom. Hot edge isn't R1. Hot edge is 0.9, okay? But it's the same thickness right the way through. So we have to thermal model this to prove our R values, which we've done. Now, if you've got a system that tapers at the top, which some people are showing, so it tapers there and then steps back out. If that's not thermally modeled as a system, they can't use AS1 either tables because it's a full board, the same thickness. So every manufacturer needs to have those tables. And if they just say refer to that, then it would be incorrect unless it was a to make the XPS board R1, it would need to be a little bit thicker. I think it's around 30 mil. And the hot edge is 25. So you're dealing with more hold down bolt issues, and so it's important that whoever's giving you that information has actually had it modeled unless it perfectly matches the tables.
Sure. Is there a maximum insulation thickness for the slab edge?
Yeah, when we first started down this process, we looked at 25 mil and 50 mil. So basically R1 and R2. I mean, if you want to round up a bit, and the difference was small. Your best result goes to an R1 at 25 or 30 mils. And then after that, the numbers just drop off completely. You get very tiny improvements, and I've seen brands did some work on this also, and they came up with the same solution. So there's no limits. I still do see people using a 50 mil edge insulation. It's just how do you deal with that with your cladding and your, so we worked out that 25 is pretty optimal.
Okay. We've got a lot of questions about the integration of underfloor heating. So one of the questions here is, can the R3 values be achieved with only underfloor insulation when using a heated floor?
Heated floors, it's definitely more difficult to achieve. So what we assessed, the most highly insulated slab we assessed would be hot edge extra with a 75 mil of XPS underslab. Those results are really good and can often achieve greater than R3, but it all depends on the area to perimeter ratio. If it's a heated floor, area to perimeter ratio 2.3 or more, then that achieves it. The underslab XPS and a hot edge extra, that does achieve R3, so not necessary. If you get to a lower area to perimeter ratio, unfortunately, we don't have a solution. The solution could be as simple as just going to a thicker XPS underslab, and you'd probably get over that threshold pretty quick. But you may need to prove that through thermal modeling from an engineer, thermal engineer.
What's the bearing capacity of the edge beam when using a hot edge base insulation under the edge beam?
The hot edge base is made from a VH grade EPS, so very high density extruded polystyrene. Its compressive strength is what you're looking for. So it's at 2% compression. It needs to be greater than 100 kPa. The 100 kPa is what we consider to be good ground. And the VH grade is 140 kPa. So it's higher than what's considered to be good ground. So there's no reason why it can't take the loads of exactly what a beam would have taken prior to insulating. And that goes for the other question, then that will be written to the Firth code mark, and we've done the work.
Yeah, right.
Yeah.
And I know you spoke about the code mark there,
Yeah.
but perhaps again, just to reiterate, one of the questions we got was, will the new code mark allow us to use underslab insulation without hot edge? And will the code mark allow us to use hot edge and underslab insulation without the need for an engineer's PS1?
Yes, yeah, that's what we're currently working on. So it will include underslab insulation in all the forms that we've assessed, and yeah, we're not going to be selling underslab insulation, but we've found solutions for your smaller AP ratios and your heated floors. Yeah.
How do we achieve R value when using block work for the perimeter foundations?
I would think the easiest way is just to insulate the slab. So underneath your slab, possibly eliminating the beams, your block work beams, if you like. Or I have seen, and we have supplied hot edge, because we can do custom boards where people will apply 600, 700 hard mil custom hot edge board to the face of a block foundation wall. So it is possible to do that and then insulate it in total. Where you've got a riprap floor not on a level site, and you've got a block wall on one side, what you could do is run your edge insulation on 3 sides, eliminate it on the last side, use the calculator to do the correction, saying this section doesn't have edge insulation. So that could be a solution.
Okay, we also received a lot of questions about the use of different claddings within the building. So how should we approach slab calculation when different claddings are used around the perimeter?
Again, the calculator doesn't exactly allow for this, but in the same sense, in a correction basis, if you ran your full perimeter, so your full area perimeter, ran it with your brick veneers, and then ran it again, the full parameters, your area perimeter with your cladding, and then it's based on a percentage. So if you took a 30% veneers, multiply your R value as a percentage on each one. So your veneer R value, your framing R value, 70, 30, and add it to the 2 together, will give you a result.
And our final one I think we'll do today, how will a non-habitable to habitable space be converted into a living space? How will a non-habitable to habitable space be converted into a living space to be compliant?
If it was built prior to this and was consented before the 1st of May, then it's a concrete slab on the ground and was deemed to be 1.3. No changes to the slab would be needed. So the changes would come in the wall, because now you need to meet, it could be an alteration, so the wall insulation would need to comply, roof insulation and windows would need to comply, because they would be new. If it was a project going forward, going into submission now, and there's a chance that the garage area may become a habitable space in the future, it may be best to consider that in the design, so that it's impossible to install underslab insulation to a floor. So if it was something that was be possibly changed in the future, may be considered now at design stage. Edge insulation can be applied as a retrofit, so that could be an option.
Yeah, okay. So some future proofing thoughts there.
Future proofing, yeah.
That's we will leave it today. I want to thank everyone for joining us. Please remember Firth are there to help with any of your technical queries. I know Greg and his team are only too happy to assist with your projects. So any queries, please feel free to get in touch with us via SmartSpec or directly with Firth. We certainly know they do a great job. I want to remind everyone that there is a further webinar coming up in the series. The next module will be on doors and windows. So look out for your invitation to join us for that. And I want to thank you for your support and have a great day and bye for now.